Lesson 12.10, exact value of trig functions in radians. So we've already done this, but with degrees. Now we're going to have to figure out the same thing, but in radians. So I drew the three special right triangles. I want you to know that across from the smallest angle, the 30, that this short leg is a half, 0.5. The long leg in a 30, 60, 90 is square root of 3 over 2, which we've learned as a decimal is like 0.8 something. That rounds up to really 0.9 because our hypotenuse is always 1 in the unit circle. And so I could do the same thing for this triangle where 60 might be my reference angle. Still the short leg across from the 30 is a half. The longer leg is square root of 3 over 2. And then a 45, 45, 90 is even easier. Both legs are square root of 2 over 2. So this will help give you a guide. I'm wanting you to try to memorize these triangles though. And then we also learned what a radian is, or we learned really the conversion is that we have a semicircle equaling pi. So 180 degrees equals pi. All the way around then would be 2 pi. And I want to break this up a little bit more. If I had a 90 right here, 90 degrees, if I want to be between 0 and pi, that would be a half pi, or pi over 2 is how you would write it. If I want to be 1 pi plus half a pi, 1.5 is 3 halves of pi, or 3 pi over 2. Other things that we need to know are my 30s. Think about 30 degrees. 30 out of 180 would be a sixth. So this is your pi over 6. Then I have my 45. Think about 45 degrees out of 180. Let's see, 45 and 45 would be 90, and 2 more 45s would be 180, so this is a fourth. So we would have our pi over 4, and then our 60 degrees out of 180 would be a third of pi, so this would be pi over 3. And so I've got my pi over 6, pi over 4, pi over 3. We're going to kind of use that to help us with this part. So it says, find each trig value in simplest form with a rational denominator. Tangent of 2 pi. 2 pi is a complete revolution. That's right here. And so when it's a quadrantal angle, when it lands on one of the axes, we just need to think about the ordered pair here, which is right 1, then up or down 0. And remember, tangent is y divided by x. So if I took 0 divided by 1, that means it's simply 0. All right, next one, tangent of pi over 2. Pi over 2, think of this as half of pi, which is 180 degrees. Half of 180 is 90 degrees, so I'm really finding tangent of a 90. And then that point would be up here at 90 degrees. That is the point 0, 1. So if I were to take y divided by x, 1 divided by 0, that would get me undefined. And then cosine of 3 pi over 2, we've got it labeled here, but this is 3 halves of pi, or 180. Half, or 180 divided by 2 is 90. 3 90s would be 270 degrees. So that puts me down here at the ordered pair 0, -1. Cosine is simply the x value, so that would be an answer of 0. All right, number 4. Think about taking pi, or semicircle of 180 degrees, divided by 3. That means it's 60. Cosine of 60, that's the adjacent leg to your 60 degree angle, that would be a half. Okay, then we have sine of pi over 4. 180 divided by 4 would be 45 degrees. So you're finding sine of a 45. That's your isosceles triangle, so both legs are the same, but we're really looking at the opposite leg for sine. That would be square root of 2 over 2. And then number 6, we have a 180 degrees divided by 6. And that would be tangent of 30. Tangent of 30. So we're taking our y divided by x, our opposite divided by our adjacent. 1/2 divided by square root of 3 over 2. can't divide fractions, sorry. So it'd be 1/2 times 2 over square root of 3. Cancel out the 2's, I get 1 over square root of 3, but I rationalize, and I get square root of 3 over 3. So tangent of a 30 is square root of 3 over 3. Okay, and then the only thing we add to that is now going in different quadrants. So the first 3 were all on an axis. The second 3 were in quadrant 1 where everything's positive. These are all going to be somewhere else, and we have to figure out the sign of them. So number 7 is sine of 2 pi over 3. Think about, ignoring the 2, what's a third of pi of 180? We said that was 180 divided by 3, that's 60. We want 2 of those thirds, so that would be 120 degrees. Okay, but what I can really think about is still sine of 60. Sine of 60, so go from here, the opposite to 60 is square root of 3 over 2. The only question is, where does 120 degrees fall, in what quadrant, and then what is sine in that quadrant? And so sine of 120 would be in here, where y is positive, so this would still be positive. And then number 8, tangent of 3 pi over 4. 180 degrees divided by 4, that's your 45-degree reference angle. So that's really all I need to know to get the angle, or the side length. And then 3/4 of pi. 3/4 of the way would put me here. That would be 135 degrees, because I'd have 45 would put me at 90, plus 45 be 135. And so tangent in this quadrant, since it's y divided by x, a positive divided by negative is going to be a negative. Tangent of my 45, think you're dividing this by itself, that would be a value of 1. And then number 9, we have a 1/6. So think of 180 divided by 6, or 1/6 of 180, that would be a 30. 11 30s, that would be sine of 330, which is right here. And we want to know this opposite side, which I know it's negative because it's going down. And then I want to know sine of a 30. This short leg here is a half. So it'd be negative 1/2. And that's it. But you're really using these same numbers all the time. Just trying to figure out what quadrant is it in, because of the other degrees that it is, or thinking of pi as a semicircle and breaking your semicircle up.